Hi, I'm Dustin Fisher, and today we're going to be working on wavelength and amplitude. So to start off, we're going to watch a YouTube video called Waves for Kids, Wavelength and Amplitude.
Find out why? We have to learn about waves. I'm Dr. Jeff Binnicker, and today we're going to explore the science of wave properties. With Dr. Jeff! This is a wave tank. Hit it! Looks like the waves are just moving from one side of the tank to the other. Interesting observation, Izzy. What do you guys think would happen if I take this ball and put it into the wave tank?
I think that it'll move with the wave from one side of the tank to the other.
I think it'll just bob up and down. Let's find out. Nailed it.
It's moving up and down, but not in the direction that the wave is moving.
Exactly. Matter doesn't move through waves, only energy does. We can understand more about waves by adjusting the settings on our wave generator. Looks like the adjustment is making the waves get closer together. Right. The distance between wave peaks is called wavelength. The shorter the wavelength, the more energy a wave has.
What if I change the knob labeled amplitude?
What do you notice?
That adjustment made the wave smaller.
Right. Amplitude is how tall or short a wave is.
Can you measure amplitude and wavelength?
Yep. Scientists do it all the time. The amplitude is the distance from the wave's peak to its resting point, which is the level of calm water. The wavelength is the distance from peak to peak. Hey kids, you want to watch this whole episode and...
Now let's practice on our own, making our own wavelengths. So what you're going to need is a rope or a slinky. A slinky would work best so you can see better waves. Unfortunately, I do not have one, so I'm going to use this rope. You're going to want to tie it around something stable. You could use a chair as long as it doesn't fall over, but I recommend a door because it won't move as long as you have it shut. So you're going to tie it around. Make sure it's tight. Now you're going to take the other end and you move your hand up and down. See how when I go up and I come back down, it forms a wave and goes all the way to the doorknob. So you're going to practice doing it, making your own waves. You can do some slow ones. You can go faster. You can try and go slower. You can try and go higher. Practice that a couple times. See if you can make different waves. See if you can make them higher, faster, slower. Maybe you can make them smaller. See what combinations you can come up with. So now I'm going to explain what wavelength is. Wavelength is the distance between successive crests of a wave. So what that means is it is two waves in a row. And it is the distance between the two. So if this is the first wave and I'm moving across this wave, this would be the second wave. So to measure that, you go from the middle of the peak of the first wave to the middle of the peak of the second wave. So you can measure just like this. So in this case, this wavelength is 12 inches. Or you can use centimeters. It is 30 centimeters. That's how long this wavelength is. Now to figure out amplitude, you measure from the peak of the wave to the rest position. This part of the rope right here is the rest position. So if the wave was normal, there was no change in height, I guess what you could say is if the water was flat, there was no wind that day, the water would sit here. But as soon as it starts getting windy, waves start to form. So this here is the rest position, where no wind or anything is affecting it. So now we have our waves again. So to measure the amplitude is now the technical scientific definition of amplitude is the maximum amount of displacement of a particle on the medium from its rest position. To make amplitude easier to understand, it's the height of each wave compared to the height it would be if there was no wave at all. So to show this, again, here's the rest position, here's the height of the wave. You can measure, again, you can go in inches, so there's 0 at the wave at the rest position, and here's the peak. So this wave would be 4 inches and 3/4 inch. 4 and 3/4 inches. This wave is just about the same, 4 and 3/4 inches. You can also measure it in centimeters, depending on what your standard unit is. So we have 12 centimeters. And this one here is just under 12 centimeters. Now, you practice taking a rope and making different waves and finding the rest position and measuring from there. To practice measuring and making waves and measuring the wavelength and amplitude, you can use either a rope or you can use Play-Doh. Play-Doh would work really well because you can roll it out and then you can place it up against a cereal box or something, and you can measure your two wavelengths. Again, wavelength. Or when you would have your Play-Doh rolled out against the cereal box, you can go and measure your amplitude. That is one way you could go and do this yourself at home. After you have had your chance to practice, you can use my worksheet that I'm providing in this lesson and practice measuring the wavelengths. Again, remember, that's from the top middle of one wave to the middle of the peak of this next wave right after or before it. That's the distance. That is the wavelength. Or you can also practice measuring the amplitude. On the worksheet, there is a few different amplitude heights. There are a few that are shorter. There are a few that are taller. This will give you multiple chances to practice measuring the wavelength and amplitude.